So today we're talking about section 1-6, which is relations. Now, a relation is, simply put, a set of ordered pairs. Does everybody know what an ordered pair is? It's the point on the graph, and it's the x comma y. Remember that? Okay? It is a set of ordered pairs. So when we are looking at relations and we're talking about a set of ordered pairs, we're going to use set notation. You guys remember the little curly Q brackets that everybody has a difficult time writing? That's how you're going to write your relation. Okay? These are your vocabulary words, and I want to tell you, look here, I changed my mind. You don't have to write the words. Just read them. Be familiar with them. So, this is a diagram of the coordinate system. Okay? You need to know all of this vocabulary. Okay? So, the coordinate system is formed by the intersection of two lines, the horizontal and the vertical axes. Okay? The horizontal axis is the x-axis. The vertical axis, the up and down one, is the y-axis. Okay? The entire thing is called the coordinate plane. When you graph a point, okay, you use an ordered pair. When you graph a point, you use an ordered pair. Here we have 2, 3. Okay? 2, 3. Where the 2 represents the x coordinate and the 3 represents the y coordinate. Now, an ordered pair is a set of numbers or coordinates written in the form x comma y. And again, the x represents the horizontal movement. Okay, x represents the horizontal movement, and the y represents the vertical movement, whether it be up or down. If the x is positive or negative, that tells you whether or not you're moving to the left or to the right. If the y is positive or negative, that tells you if you're moving up or down. Is everybody clear? All right. And again, as we said in the introduction, a set of ordered pairs is called a relation. And a relation can be represented in several different ways. We can write it as an equation, as a graph, with a table, or by mapping. All right, so this is an example of a mapping diagram. This is an example of a mapping diagram. It shows you how the domain values are paired to the range values. The domain, bless you, is a set of, are the x values. The domain are the x values. Another name for the domain is the input. Okay? And the domain goes in the first circle there. Okay? The second set of numbers is called the range. And that range represents the y values. Okay? Another name for the y value and the range is the output. So the input are the x values or the domain, and the output are the y values or the range. Clear? All right. Good. If we look at this mapping diagram, you'll see that all of the x values are in the domain. Okay? And all of the y values are in the range. But notice, I have 4, 4, 6, 8, 8. And in the range circle, we only have 4, 6, and 8. We do not write the repeats. Okay? You do not write the repeats. So, here are the different ways that you will see a relation. Okay? You can see a relation as a set of ordered pairs. You can see a relation organized in a table. X comma Y, X comma Y. Okay? You can see a relation displayed on a graph. And as a mapping diagram, as we just discussed. When we look at this, the relation here, 1 comma 2, negative 2 comma 4, 0 comma negative 3, that is the relation. And in that relation, all of the x values, 1, negative 2, and 0, those are the domain values. Okay? 2, 4, negative 3. Those are the range values. Okay? Now when you write them, as the domain values and the range values, normally you would write them from these degrees. Okay? So let's take a look at some examples. So example 1, we are looking at the representations of a relation. And again, we want to express this relation as a table, as a graph, and as a mapping diagram. Remember, in the mapping diagram, the x values are the domain, goes in the first circle. The range, or the y values, go in the second circle. When we are graphing, we graph the horizontal movement first, and then the vertical. Okay? So we graph the x first, and then the y. Okay? So, also, this is what I was telling you earlier. See those little curly cues right there? That is called set notation. You have your brackets, and your ordered pairs are separated by commas. That is your set notation. Okay? All right. So, the first thing I want to do is I want to express the relation as a table. Okay? So all we're going to do is we're going to look at all of our x values. Those are the x values. Do I have any repeats? No. So now I can just write the 4, negative 2, 2, and 0. Those are the x values. Now you want to write the y values that correspond to each one of them, right? So the y values that correspond to each one of those is 4 comma 3, negative 2 comma negative 1, 2 comma negative 4, and 0 comma negative 4. And that is how you display in a table. Okay? In a table, you must write the repeats. Okay? In a table, you must include the repeats. All right? And then we graph x comma y. All right. So now we're going to graph. Okay? So 4 comma 3. So always start at the origin. We go to the right 4, and then we go up 3. So there is 4 comma 3. Negative 2 comma negative 1. Again, you start at the origin. Negative means you go to the left. 2, and then the negative y value is negative 1. So you go down. Okay? and then you can do the rest. And that is your relation displayed in the coordinate grid or the coordinate plane. So now for the mapping diagram. Again, the x values go in the first circle. So we have 4, -2, 2, and 0. The y values go in the second circle. And remember on that one, what? We don't write the repeats, right? So we've got 3, -1, and -4. And then, to show the mapping, you just draw your arrows. Okay? So, 4 maps to 3. -2 maps to -1. 2 maps to -4. And 0 also maps to -4. So 2 maps to -4. And 0 maps to -4. Example B says determine the domain and range for the relation. We've already talked about this. Another name for the domain is what? The x value, or the input, right? Let's write input on there too. And another name for the range is what? The y value or the output. Okay? So when I identify the domain and range, we have it right here. The x values, and we want to write them using set notation. Okay, so we're going to use our brackets, and we're going to separate each value with commas. So we have the domain values. We have 4, -2, 2, and 0. Okay? The range values are the y values. And when we list the y values or the range as a set of as a set, we don't write the repeats. Okay? So this is going to be 3, -1, -4. And there you have your domain and range. All right, there's your solution for example 1A. You've got your table, you've got your coordinate grid, and your mapping diagram. Okay? Then, determine the domain and range. The domain are the x values, and the ranges are the y values. Very good. And when we write it using our brackets, separated by commas. So you want to put it in set notation. And there's your domain and range. Got it? All right. All right. In a relation, the value of the variables that determines the output is called the independent variable. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. All right. In other words, okay, the one that does the affecting, the one that causes the change, that one is the independent variable. Okay? The one that causes the change, you should write this down. The one that does the affecting or causes the change is the independent variable. the one that gets affected, or the one that gets changed, or the one that changes, that one is a dependent variable. Okay? So, identify the independent and dependent variables for each relation. The dance committee is selling tickets for the fall ball. The more tickets they sell, the greater the amount of money they can spend on the decorations. So which one do you think does the changing? Or causes the change? Yes? The number of tickets. Okay? So the number of tickets they sell is the independent variable. The more tickets they sell, the more decorations, or the better decorations they can buy, right? So, the money they spend on decorations is the dependent variable. You got that? All right. Let's see. Generally, the average price of going to the movies has steadily increased over time. What do you think causes the change? Oh, I have it up there. What causes the change?
I was about to say something, but I realized that's nothing good from the equation.
Okay. What do you think? In the 1970s, it only cost about $1 to go to the movie. Okay? Now it costs $10. What do you think is causing the change?
Inflation.
But what causes that? Time. Time is the independent variable, right? Very good. That's the one that causes the change. And then the price of the movies, that's the thing that gets changed. That's the dependent variable. You got it? Good. So let's see here. For 2A, we want to identify the independent and the dependent variables. Okay? The air pressure inside a tire increases with the temperature. Which one is the independent and which one is the dependent? Which one does the changing and which one gets changed? Come on, let's see. Somebody hasn't called on yet. All right, for example, 2B, as the amount of rain decreases, so does the water level of the river. So the decrease in the rain causes the change of the water level. So that means that our independent variable is the rain, and our dependent variable is the water level. Okay? Good. So here, a relation can be graphed without a scale on either axis. These graphs can be interpreted by analyzing their shape. So the first example says the graph represents the distance Francesca has ridden on her bike. Describe what happens in the graph. As time increases, the distance increases until the graph becomes a horizontal line. So time is increasing. As time increases, the distance remains constant. So at this point, Francesca is stopped. And then she continued to ride her bike. Okay? If we look at the examples below, here describing what is happening at each graph. Here, this is driving to school, for example. Now, at this point, as time increases, okay, in a short period of time, the distance traveled increases a great deal. So at this point, you can say that maybe the person is driving 55 miles an hour, 45 miles an hour, or what have you. And then what happens here, maybe that person has then entered the school zone, and then the speed limit goes slower. So as time goes by, the distance traveled is smaller. Okay, I want to point one other thing out here. If you look at these points right here, where the graph is completely horizontal, just as with Francesca on her bike, here at those horizontal points, the car is stopped. Okay, because as time increases, the distance stays the same. And since it stays the same, that means that the car is not moving. Okay? Very good. All right. And then here for the change in income, you can see that for the whole graph, as time increases, income generally increases at a steady rate. Right here, perhaps this person was working overtime, and their income increased, and then their overtime was over, and then they went back to their regular pay scale. All right, and that's that.